Welcome back. We're diving back into the OEIS today.
Always a good time.
Yeah, we love these sequences. And we've got a really interesting one today, a 000127. Might seem kind of simple when you first look at it, but there's actually a lot going on here, especially for those of you out there, our number theory students. Get ready to make some connections to some concepts you already know.
Yeah. 000127. It really shows you how a sequence that seems really simple, it can actually take you down like this rabbit hole of math, lead to all these cool insights.
Okay, so let's start with the basics. Like, what exactly is this sequence, a 000127?
So this sequence, it gives you the maximum number of regions that you can make inside a circle by connecting points on the circumference with straight lines.
Okay, I can see that.
So think of it like you're slicing a pizza.
Yeah. I was just thinking that, like the pizza analogy.
You got it. But the key is you have to make straight cuts, like from one crust to the other.
Okay.
And then A000127, that tells you the most slices you can get with like a certain number of cuts.
I like it. That makes sense. Okay, but wait. The OEIS entry, it also says that A000127 represents regions in four-dimensional space, like formed by these things called hyperplanes.
Yeah.
Can we even picture that? Like, can you help us understand that?
Okay, so think about slicing a loaf of bread. Each cut you make, it makes a new surface, right?
Right.
Okay, so imagine you do something similar in four-dimensional space. But now, each slice, each cut, it's a hyperplane. And these hyperplanes, they divide the 4D space into regions. And A000127, it tells us the maximum number of regions we can get.
Okay, so we're taking this idea of dividing space into regions. We're going from 2D with the pizza to 4D. With the bread and the hyperplane.
Exactly.
Okay, I kind of get it. And
it's really interesting that the same sequence applies to both of these situations, right? Like it kind of hints that there's some deeper mathematical connection there.
Right. Absolutely. Okay, well, speaking of connections, let's talk about the formulas. For A000127, the OEIS entry, it lists binomial coefficients. There's a polynomial formula, and there's even generating functions in there.
Yeah.
And I don't know about you, but I immediately thought back to, I think it was our episode on Pascal's triangle.
Right.
Do you see a connection there?
Absolutely. So the binomial coefficient formula for A000127, it directly connects to Pascal's triangle. Remember, each row in Pascal's triangle, it shows you the coefficients of a binomial expansion, right?
Yeah.
Well, the formula for A000127, it uses a bunch of those binomial coefficients, specifically from the n1th row.
So the number of regions we can create, whether it's the circle or this crazy 4D space, it's actually tied to the patterns in Pascal's triangle.
Yeah, exactly. And there's even more to it. Like we have all these different ways to represent the sequence. We have binomial coefficients. We have this polynomial formula, and we even have those generating functions.
Right.
And this really shows us a key principle in math. Having different perspectives can be really powerful.
I can see how all these things we thought were separate, they actually connect in these like unexpected ways.
Yeah.
So for our number theory students out there, can you talk a little bit more about why having all these different representations is important?
Well, think of it this way. Each of these representations, they give us different tools to like analyze and understand A000127, like the binomial coefficient representation that shows us the combinatorial side of things, like how many ways can we put these lines together to make different regions. The polynomial formula gives us a really quick way to calculate a specific term.
Okay. And what about the generating functions? Like, what insights do they give us?
Yeah, generating functions, those are a bit like, I think of them as mathematical fingerprints for sequences.
Okay.
They take the whole sequence and they pack it into a single function.
Uh-huh.
And that lets us study the properties of the sequence in a different way. And for A000127, the OEIS entry, it gives us both rational and exponential generating functions.
Okay, so by looking at these generating functions, can we see hidden patterns or maybe relationships that we wouldn't see just by looking at the numbers in the sequence?
Exactly. Generating functions can show us connections to other sequences. They can help us figure out how fast the sequence grows. And we can even use them to find new formulas. They're a really powerful tool, something that number theory students should definitely have in their toolbox.
Okay, I'm seeing how each of these representations, whether it's binomial coefficients, the polynomial formula, or the generating functions, they each give us this unique way to explore A000127. But there's something interesting about the sequence itself. The first few terms are 1, 2, 4, 8, 16. It looks like powers of 2, right?
Yeah, it really does, doesn't it?
Right.
And that's part of what makes this sequence so interesting. It seems like it has this simple pattern, but then it kind of throws you a curveball.
Right, because the sixth term, it's 31. It's not 32.
Exactly.
So it's not just powers of 2.
This is a classic example of why we can't just rely on what we see in math. We need proof to really understand the patterns and the relationships. A 00000127 is a good reminder that our intuition is a good starting point, but it's the proof that gets us to that mathematical certainty.
A very important lesson for any number theorist out there. Okay, so we talked about A00000127 in terms of dividing up circles and even four-dimensional space with the hyperplanes, but the OEIS entry, it also lists connections to other sequences. It's like A000127 is part of this bigger mathematical web.
It is, yeah. Like if you look at A0000000125, which is the maximum number of regions you can make in 3D space by slicing it up with planes. And there's even a link to A000124, which looks at regions on a sphere.
Okay, so it's like we're seeing this progression from points on a circle to regions in higher dimensions. Is there like a deeper connection between these sequences?
What's really cool is that these connections suggest some deeper structure underlying it all. Like if we explore how A000127 connects to these other sequences, it can give us insights into how geometric ideas work as we move into higher dimensions. It shows how different parts of math are all connected.
It's like we're zooming out and seeing the bigger picture, how these ideas we thought were separate are actually all linked. Okay, so we know A000127 is mathematically cool, but are there any real-world uses for it?
Oh, absolutely. Think about urban planning. Like if you're designing a city that's shaped like a circle and you want to divide it into zones using roads, a 000127 could help you figure out how to get the most zones with a certain number of roads.
That's interesting. So understanding how to make the most regions could be really useful for designing cities and making the best use of space. Are there any other practical applications where A000B0127 is useful?
Definitely. Think about computer graphics. When they're making those complex 3D objects, the algorithms they use often have to break up curved surfaces into smaller pieces. A000127 could help them develop better algorithms for dividing up circles or spheres in computer graphics and 3D modeling.
So A0000127 goes from theoretical geometry to practical stuff like urban planning and computer graphics. Pretty impressive reach. But you mentioned some even more interesting applications, something about cryptography and coding theory.
Yeah, and this is where things get really exciting, especially for our number theory friends. Remember we talked about how I000127 is combinatorial and it connects to binary numbers? Well, these things could lead to new ways to design secure communication systems or create efficient ways to code data.
So a sequence that starts with simply dividing a circle could actually impact the security of our digital world.
It's definitely an area that needs more research. But the potential is huge. It shows how even abstract math ideas can have a real impact in all kinds of fields.
This has been incredible. We started with dividing circles, and now we're talking about binomial coefficients, hyperplanes, Pascal's triangle, and even cryptography.
Yeah, and we've seen how A000127 is a perfect example of the connections in math and the importance of looking at things from different angles. It reminds us that exploring and finding links between seemingly unrelated ideas can lead to some pretty amazing discoveries.
What an awesome deep dive into A000127. For our listeners, those of you who want to dig a little deeper, I have a challenge for you. We've talked about how A000127 relates to dividing regions in a circle, right? Even four-dimensional space. What about other dimensions?
Oh, that's a great question. It really makes you think. Is there like a whole family of sequences where each one tells you the maximum number of regions in a different dimension?
So like we have one sequence for a line, another for a circle, then 3D space, then 4D space, and so on.
Exactly.
Is there some kind of, I don't know, like an overarching pattern or a formula that connects all of them?
That's the kind of question that keeps mathematicians up at night. You know, if we could find that one thread, that elegant formula that captures how regions are made in any dimension, that would be a huge discovery.
It just shows that even with a sequence like A000127, that's been studied so much, there are still mysteries to solve, new things to discover.
Absolutely. The OEIS is amazing for sparking that curiosity, you know, that drive to explore and push the boundaries of math.
This deep dive into A000127 has definitely gotten me thinking. I'm going to be pondering those higher dimensional connections for a while.
Yeah, I hope all our listeners will too. Dive into the OEIS, explore the formulas, see what connections you can find. You never know what mathematical adventures are out there waiting for you.
That's a great way to put it. And remember, you can find all the details about A00000127 and all the related sequences on the OEIS website. So, until next time, keep exploring, keep diving deep into this incredible world of number theory. You know, this deep dive into A000127 has really opened my eyes. I'm starting to see these sequences everywhere now.
I know, right? It's like once you start noticing these patterns in math, they just pop up everywhere.
Okay, so we've covered a lot of ground today. Binomial, coefficients, hyperplanes, those fascinating generating functions. But before we wrap up, I want to throw one more idea out there for our listeners.
All right, let's hear it.
We talked about how A000127 can represent regions in a circle, and even in four-dimensional space. What about other shapes like squares or triangles?
That's an interesting thought. Could there be a similar sequence for like the maximum number of regions you can create inside a square by connecting points on the sides with straight lines?
Exactly. Could we apply the same kind of combinatorial thinking and maybe even find connections to other mathematical concepts like we did with A000127?
That's a fantastic challenge for our listeners to explore. It would be like extending this deep dive into a whole new dimension, literally.
And who knows, maybe there's a hidden connection between the sequences for circles, squares, and triangles just waiting to be discovered.
I wouldn't be surprised at all. Math is full of these unexpected connections. That's what makes it so fascinating.
Well, on that note, we reached the end of our deep dive into A000127, a sequence that started with simply dividing a circle and led us to explore some truly mind-bending concepts.
It's been a journey through different dimensions, mathematical tools, and even potential real-world applications.
A huge thank you to our expert for guiding us through this fascinating world of number theory.
It's been my pleasure, and remember, everyone, the beauty of mathematics lies in its endless possibilities. Keep exploring, keep questioning, and who knows what incredible discoveries you might make.
To all our listeners out there, keep those OEIS entries coming, and we'll see you on our next deep dive into the fascinating world of numerical sequences.